I want to look at dilution calculations today, and we're going to look at two different types of problems. In the first one, we're trying to prepare 475 milliliters of a 0.50 molar solution, and we're doing that by diluting a solution that starts out at 12.0 molar. And we want to figure out how we do this. Whenever we do one of these dilution problems, we want to start out by saying what we know, tabulating what we know and what we don't know. So in this particular case, we know we're starting with a 12.0 molar solution. We don't know how much of that solution we're using, or going to use, that's our unknown. And we want to make a solution that's 0.50 molar, and we want 475 milliliters of that solution. In this problem, we're going to use our dilution relationship, which is M1 times V1 equals M2 times V2. So I'll fill in my values. 12.0 molar times our unknown volume equals 0.50 molar times 475 milliliters. And when we do this calculation, we find that our V1 is 19.8 milliliters, or to the correct number of significant figures, 2.0 times 10 to the 1 power milliliters. So what we're going to do to prepare this solution is we're going to take that volume and dilute it to 475 milliliters. You'll notice I can work in milliliters here. I don't have to convert to liters as long as I have the same units on both sides. If I have milliliters on one side, I need to have milliliters on the other side. If I have liters on one side, I need to have liters on the other side. Whatever my units are on one side, I need to have the same units on the other side. The second problem I want to look at is this one. We start with 221 milliliters of a 0.12 molar calcium chloride solution, and we add 145 milliliters of H2O to it. What's the final concentration of calcium chloride? Well, again, we want to start this problem by tabulating what we know. And we know we're starting with 0.12 molar, and we're starting with 221 milliliters of that solution. We don't know what the final molarity is going to be, but we know that after we finish mixing all the solutions, our new volume is going to be the original 221 plus the 145 that we added, for a total of 366. And you want to watch that. You don't want to just say, oh, my new volume is going to be 145, because it's not. We're adding 145 and 221 together. When we substitute into our dilution relationship, we have 0.12 molar times 221, our M1 and our V1, is equal to M2 times 366. And when we solve that, we find that the concentration of calcium chloride after this dilution is 0.72 molar. What if I had asked instead, what's the concentration of the chloride ion? Well, in order to do that, you have to note, or answer that question, you have to notice that every one calcium chloride unit has 2 chloride ions. So the way we would do this calculation is to say that the molarity of our calcium chloride, 0.72 molar, times 2 chloride ions for every 1 calcium chloride equals 0.14 molar chloride ion. One last thing I want to point out to you about these dilution calculations. People have a tendency to use this M1 V1 equals M2 V2 relationship when they shouldn't. They'll see 2 solutions, 2 different concentrations, and they'll automatically plug into M1 V1. And you don't want to do that. You only want to do that when you're doing a dilution. You don't want to do it when you're doing, for instance, a chemical reaction. A lot of people will use it when they're mixing an acid with a base in a titration type problem, and that's not what you want to do. That is a stoichiometry problem, and you want to treat it as a stoichiometry problem.